Now that you have learned in the previous episodes how the ecosystems function in the deep sea and how the machinery might look like that we would use for mining, we want to explore the possible impacts that we might have on the life down there.
Let's imagine we are this big vessel cruising to the middle of the ocean to start our mining mission. On the way, we release emissions of the fuel we use. The carbon accumulates in the atmosphere and heats our planet. We also have quite a loud engine, and the sound travels much faster and further in water than in air. Loads of animals can hear us. After a while, we reach our site. Thousands of meters of water lie beneath us. We lift our machinery into the water. Slowly, it sinks towards the bottom. It reaches a vast, untouched area, and on our cameras we can already see the nodules covering the ground. When we touch down, we realize how soft the sediment is down there by the plume that we've created. We turn on our big headlights. The usually dark, deep ocean floor suddenly clearly visible. Animals can see each other, can't hide in the dark anymore. How largely this might impact the environment is not fully understood. We turn on our engine. Again, our noise spreads across the usually quiet ocean floor. We start our track, digging up the nodules. Line by line, we follow the plan. Behind us, we leave a trace that will be visible for decades to come. Experiments have proven, even after 30 years of a trial digging, the track is still clearly visible. Meter by meter, we take the metal, the hard substrate that the animals used to live on. But we also take most of the upper 10 centimeters of the sediment in the process. It takes thousands of years to build this nutrient-rich layer. Here, all the bacteria usually live, play part in the nutrient cycle, and provide the basis for life. The ground is now also compressed from the heavy weight of our digger. New life will have a hard time settling here. Research shows that the biodiversity is significantly lower in areas that have been mined, and those were only trials for research purposes on a small scale. It takes a long time for the ecosystem to recover, probably much longer than a human life. If it even ever will, we don't know. While we keep driving along the seafloor, the nodules make their way up towards the surface in big tubes until they reach the mothership. We don't want to bring home all the additional weight of the sediment that got sucked up in the process. So we separate it from the metal and send it back to the ocean. In again a long tube, it sinks back towards the floor. After a while, the tube ends and the sediment disperses in the water. Slowly, it sinks back to the seabed, spreading many kilometers in the meantime. As it reaches the ground, it buries the life underneath. Experiments have shown that, for example, worms called nematodes can only survive a certain coverage. If buried too deep, they die. And just like most processes in the deep sea, it will take a long time for those populations to recover. How exactly we could impact the ecosystems is unknown. We will destroy the habitat not only by collecting nodules, but also by mining hydrothermal vents and the cobalt crusts. Most likely, this will lead to a loss in biodiversity and therefore in ecosystem functions like the nutrient cycle that are important for us. There are areas called APEIs, areas of particular environmental interest, that are supposed to preserve the biodiversity by offering a safe spot for life in the deep ocean. To understand if and how this will help, we will have to do further research.
If you want to know more about the impacts we might have on the deep sea environment when we start digging, check out the articles and videos in the links below. Also remember, feel free to ask any questions in the comments. In the next episode, Larissa is going to interview Matthias Hecke. He's a deep sea biologist at the research institute GEOMAR in Kiel. He's going to explain to us some of the experiments they're doing to find out how much we actually impact the deep sea ecosystems by mining.